So this is a video about the sine rule in the context of non-right-angled trigonometry. So we can see in front of us a triangle there that has no right angle, and we have a distinct labelling convention in that the lowercase b represents the side length that is opposite the angle B. Likewise for C and for A. And I think just really important to recap that it doesn't matter what you label or what the sides are labelled as long as you recognise that the relationship is between the side length and its opposite angle. And that's really, really key to working with the sine rule. So the sine rule, simply stated, says that if you take the side length A and divide it by the sine of its opposite angle, then you will get the same result as if you took the side length B and divided it by the sine of its opposite angle, and likewise for C. And that's a really significant link, as it means, say for example, if I knew three bits of information about a triangle, then I could link them together in this way, provided it was the right three pieces of information, to work out the fourth. Okay, and perhaps it would be perhaps it would be those four. The point being that I can link them together with the sine rule and then solve for the one remaining unknown. Now the other important thing to recognise about the sine rule is that I could express it this way as well, with the signs as the numerators of the fractions. Each fraction is the inverse of the one corresponding in the previous version. And sometimes it helps to have it expressed that way so that I can keep my unknown in the numerator of the fraction. So it's just as true. That's the thing that's important to recognise. It is just as true written this way round. So let's have a look at this in the context of some examples. So here is a right angle triangle where I know three bits of information, this side length and these two angles. And I would like to know this side length. Now I can link them together with the sine rule because what I have here are two pairs of side with opposite angle. So I can say straight away about that triangle that A over the sine of its opposite angle 40 will be the same as 50 over the sine of its opposite angle 100. Okay, and so that's linked those four bits of information together. There's only one unknown, and so I can now solve to work out the value of that unknown. And I've multiplied both sides of the equation by sine 40 to get this, put that in my calculator, and I get 32.6 to three significant figures. And of course that should say 32.6 centimetres to three significant figures. So the example on the right, we've got three bits of information there. We've got that side length and that side length, and we've got that angle. And so now we need to think about, well, which other pieces of information that we have here can we find out with those three bits of information, sorry. Well, I definitely have a pair there. I have an angle and its opposite side, or a side and its opposite angle. I have that pairing. Now, with the 20 meters, the opposite angle is C there. So in fact, I could link those four bits of information using the sine rule. And it would say that sine of the angle C divided by 20 is equal to sine of the angle 55 divided by 35. And you'll notice I've used the other form of the sine rule there with the signs on the top because it suits me to have the unknown in the numerator. Then I will simply multiply both sides by 20, so I've got 20 sine 55 over 35, and take the inverse sine, and I'll get 27.9 degrees to three significant figures. So you can use the sine rule to link four pieces of information together about a given triangle, and as long as you know three of them, you'll be able to solve for the fourth. And so that's the skill of using the sine rule.